Hey, so this is section 2.6 on algebraic proofs. It's kind of our introduction to solving proofs. Here we do it in a what we call a two-column format. Um, you'll see that here momentarily. I'll point that out to you. Um, First, though, there's a bunch of different properties that we have to be aware of, especially when we're solving algebraic proofs. They're all listed here. They should be listed in your notes. You are responsible for pretty much knowing all of these, and in most regards, you know these, you just don't know the names that are associated with them. You know that when you add a number to one side, that you should also add it to the other side. That's called the addition property of equality. We're keeping the equalness of the equation by adding the same thing to both sides. Same thing, when you multiply something to one side of the equation, you've got to do that to the other. That's the multiplication property of equality. Some of those you may not be so familiar with are down here toward the bottom. Let's see if I can bring a pen here to highlight. Hello, highlighter. All right. So pretty much these right here, the reflexive property, the symmetric property, and the transitive property. Reflexive property pretty much says that something is equal to itself. 4 equals 4, x equals x. Ice cream cone equals ice cream cone. Um, think about when you look in the mirror, you see your reflection. Not quite the same as reflexive, but you get the idea, hopefully. You look in the mirror, what do you see? You see yourself. You don't see somebody else. The symmetric property states that the order of your equality doesn't matter. So whether you say x equals 7 or 7 equals x, they both mean the exact same thing. Transitive property has to do with connecting two things through something else. If A equals B and B is the same as C, then since A is equal to B and C is equal to B, then A and C should also be the same thing. Substitution we're kind of familiar with. It's, again, replacing something with something of equal value. The distributive property you're pretty familiar with from your algebra days as well. So, like I said, you are pretty much in charge and responsible for knowing all the different properties here. We will be using them as we go through our proofs, especially when we get into things involving segment proofs, angle proofs, stuff with parallels. They're definitely going to come into play. So make sure that you are aware of those. So we'll get started here with a couple of examples in terms of what a proof actually looks like. So here, not the greatest. You'll see some other ones are a little bit better in terms of setup. But you get an idea for what we're looking at here. So essentially an algebraic proof is nothing more than just an algebraic equation that we're looking to solve, except as we solve it, we're going to provide reasons for every step that we do. Most times, the very first thing that we see in that statement column is going to be known as our given. The reason for that is going to be given. It's our given statement, meaning that's what we're starting off with. The very last thing that we're going to see in our statement column is what we're trying to prove. So given that 6x plus 2 times the quantity of x minus 1 equals 30, we're going to try to prove that x equals 4. And so as we go along, we'll fill in different reasons. Sometimes we'll be given the reason, we're going to try to fill in the next step, essentially, of that equation. So basically, here's how it's going to kind of work out. All right, like I said, that first statement that we have there, that's what we're given. That's what we're starting with. So as you look at statement number 2, the nice thing about proofs is that they generally build off of previous steps. So when you see statement 1 here, that next step has to deal exactly with what happened before. So here we can see we've got some multiplication, some distributive properties. So if we take that 2, we multiply it through, and that's what we have here. We distributed that 2 through the parentheses, so that is what we're going to mark as our distributive property. So, in your mind now, you should be thinking, well, what would I do next? Well, we can see here that we've got some like terms, so we would probably add those together. Well, 6x plus 2x would give us 8x, and so that's going to be 8x minus 2 equals 30. All right, along with that, you notice that the next reason kind of popped up along with that. It says the addition property. The addition property of equality states whatever you add to one side, you have to add to the other. And so that's what you see here. We're adding 2 to the left, we're adding to the right. So that's our addition property of equality. So now, of course, you're saying to yourself, what would come next? Well, just simplify that equation. And where are we at? That's right, we're at 8x equals 32. All right, substitution. So you're thinking, well, what did we replace? Well, we took the 30 plus 2, and we replaced it with 32. We took this left side, and once we simplified it, we replaced it with 8x. So again, you see that we're replacing things, and so that's why the substitution property fits in really well there. Our next reason says division property. Well, again, if you're trying to solve for x here, what's the next you're going to do? You're going to divide by 8. And so we put that in there. And lastly, again, 32 divided by 8, what is that? It's 4. We're replacing something of equal value, and so that's our substitution property. So that's kind of how a proof works. The next one is pretty similar. Again, that first statement that we have there is going to be provided to us. So that's our given statement. That's what we're starting with. You can see down here at the bottom that we're trying to prove that that equation will eventually get to x equals 7. So, what about all those different steps in between? Well, you look at statement 1 here, and we move into statement 2. What do we see happening? Right, so it looks like that we're subtracting 2x from each side. So again, that goes back to our subtraction property of equality. Whatever we subtract from one side, we have to subtract from the other. As we perform that subtraction and simplify both sides of our equation, you're going to see that we're left with 4x plus 2 equals 30. So based on that, what will we do next? How are we going to solve for x? Well, we can see that our reason is subtraction property, so we should be subtracting something from both sides of our equation. Well, that's where we pull this from. 4x plus 2 minus 2 equals 30 minus 2. So as we subtract, we start combining like terms. And we see that we go from 30 minus 2 to 28, and this left side just becomes 4x. Well, again, we're replacing things of equal value, and so that's our substitution property of equality. Again, just like you would solve the equation, get the variable by itself. So we're dividing, and then lastly, again, we're replacing stuff, and so that's our substitution property. So hopefully it's starting to make a little bit more sense. On the next slide here, we've got an example that, if I were you, I would just pause the video and see if you can start to work this out yourself. After you have put things in place to where you think they belong, unpause the video, and I'll be putting things in place where they should be. Alright, so hopefully you had a chance to do this on your own, or at least give it a shot and see what pieces parts you could fit where. Basically, here's what we're looking at. So I've got highlighted here the given. This is how typically a standard proof would look in terms of providing you with something that is your starting point, the given information, and what it is you're trying to prove, in this case, that x equals 3. So again, like I said, that whatever you're trying to prove is usually your last statement, and that's going to go right there. Your first reason, given. Alright. Reason B says that we're using the multiplication property of equality. What do we notice being multiplied to both sides? Well, there's a 2 here, and we probably need a 2 over on this left-hand side. So I'm going to take the 2 here and drag it over, and now that step is done. Once we've multiplied through, what are we left with? Well, 2 times 9 is 18. We're replacing, again, you're replacing the multiplication with the actual answer, and that's substitution. In statement D, we can see that we continue to solve the equation by subtracting 6 from both sides. And that's our subtraction property of equality. Again, we're looking to simplify and replace. 18 minus 6 is 12. F says we're going to divide, and so that's where our 12 divided by 4 comes into play. And so hopefully you were able to put those pieces in place and come up with the correct proof for that example. Alright, there's one more left here. again, I would pause the video, give it a shot, see what you can come out with. Again, you have your given statement, and what is it you're trying to prove. How can we take these different pieces of information from, I guess you call it like almost like a word bank, and put those in place. Alright, so hopefully you've had a chance to try to put these different parts in place of our proof in the reasons column and in the statements column. Again, pretty much here's what it should look like. Given for the first reason. We're subtracting x from each side in statement B. You can see the statement C is already complete. We've substituted and combined all of our like terms. D says that we should be subtracting, so we're going to subtract 8 from both sides. Once you've done that, you're looking to combine your like terms. We're left with 3x equals negative 6. Hey look, it looks like we're dividing. So let's use the division property of equality. And lastly, what it is that you're trying to prove. In this case, that x equals negative 2. Hopefully that worked out well for you and gives you some insight in terms of what we're looking at in order to solve two-column proofs. Like I said, algebraic proofs and working with the equations is kind of a nice, easy way to kind of ease into the whole working with proofs process here. It'll get a little bit more difficult as we go. Hopefully this hasn't been too bad. If you have questions, let me know and I will try to answer those as best as possible. Thanks.